An aircraft this size has a pilot, a co-pilot, and a person standing at the back who can tell both of them that the aircraft is not going anywhere yet. On a cargo jet, that is not a figure of speech. The cargo compartment is not simply the empty space behind the cockpit. It is a separate machine with its own rules, its own arithmetic, and its own person in charge of it. That person is the loadmaster. And the strange thing about the job, to anyone outside it, is how much of the aircraft answers to someone who never touches the controls. Start with the thing everyone gets wrong. People assume a transport aircraft carries what fits. Volume is almost never the limit. Most transport aircraft run out of allowable weight with the compartment still half empty. The limit is weight and where that weight sits. An aircraft flies around a balance point. Load it correctly and it behaves the way the crew expects. Load the same total weight in the wrong places and it becomes a different aircraft in the air. So the compartment is not a room, it is a ruler. Every position along the floor has a number, and every number changes what a given pallet does to the balance of the whole airframe. That is why the loadmaster's job starts long before the ramp comes down. It starts on paper with a plan for where each item goes and what it does to the aircraft when it is there. The plan is not a suggestion for the ground crew. It is the shape of the flight. Change the order without telling anyone, and you have quietly changed the aircraft that is about to take off. Which brings us to the moment people actually see a ramp lowered onto concrete, an engine running, and a line of cargo waiting for permission to move. Watch who is standing there. One person, usually with a headset, usually walking backwards, with both hands up. Everything heavy moving toward that aircraft is moving at their speed. Not the driver's speed, not the scheduled speed. If the hands come up and stop, a 40-ton vehicle stops halfway up the ramp and waits, with everyone watching. That authority looks disproportionate until you understand what it is protecting. It is not protecting the cargo. It is protecting the numbers the crew is going to fly with. Because once the doors close, nobody can renegotiate any of it. Whatever is in that compartment, wherever it ended up, is what the aircraft is now. And this is the part of military aviation that almost never gets filmed. The aircraft is the easy half. The load is the hard half. Subscribe. So let us take the compartment apart properly, starting with the floor, because the floor of a cargo aircraft is not a floor in any sense you would recognize from a truck. It is a system of rails and rollers. Cargo does not get carried down the length of the aircraft. It gets rolled, guided by tracks that run the whole way from the ramp to the front. That is why a pallet weighing several tons can be moved into position by a handful of people. They are not lifting anything. They are steering something that is already floating on rollers, and when the pallet reaches its number on the floor, the same system stops being a conveyor and becomes a clamp. Locks come up out of the rails and take hold of the pallet edge. From that moment, the pallet is not sitting in the aircraft. It is part of the aircraft's structure, held by hardware designed for forces that have nothing to do with normal flight, which raises a question most passengers never think about. Restraint in an aircraft is not calculated for level flight. Level flight is trivial. It is calculated for the worst moment the aircraft is expected to survive, which is a very different number. Hard braking on a runway, turbulence that lifts everything off its feet, a steep climb out. The restraint has to hold the load in every direction, not just downward. So chains and straps are not thrown over cargo to look secure. Each one is rated, each one is counted, and the count comes from the weight of the item and the direction being restrained. Forward restraint is the heaviest requirement because the most violent thing a cargo aircraft normally does is stop. Everything in the compartment wants to keep going toward the cockpit. That is the real reason for the arithmetic, not paperwork culture. The chain count is a number that has to be produced before the aircraft is allowed to move, and it belongs to one person. Now go back to balance, because this is where the job stops being physical work and starts being engineering done in a hurry, on concrete, with the engines running. Every aircraft has a range of positions where its balance point is allowed to sit. Not a single point, a window. Stay inside the window and the aircraft handles as designed. Load too much toward the tail and the nose gets light. Load too much forward and the aircraft becomes heavy and reluctant exactly where the crew needs it to respond. And here is the part that surprises people most. The balance changes during the flight. Fuel burns off. Cargo comes out at one stop and not another. The window has to be respected the whole way. So a load plan is not one calculation. It is a calculation for every leg of the trip, including the legs where half the cargo is already gone. That is why the order of loading matters as much as the placement. What goes in first comes out last. Anything needed at the first stop cannot be buried at the front. In practice, the compartment gets loaded backwards from the itinerary. The last destination goes deep. The first destination sits by the ramp, ready to leave in minutes. Get that wrong and nothing dramatic happens. There is no failure, no alarm. There is just an aircraft sitting on the ground somewhere while people unload cargo that was never meant to come off there. And time on the ground is the one thing this whole system is built to protect. A transport aircraft earns nothing parked. The compartment is designed to empty fast, which is why the cargo does not arrive as cargo. By the time the aircraft lands, most of what it will carry has already been turned into standard shapes, out in a yard, by another crew entirely. Boxes become a pallet. The pallet gets netted, weighed, measured, and labeled. And from that point, it is not a collection of items. It is one object with one weight, one footprint, and one number that the aircraft can plan around. That standardization is the whole trick. The loadmaster is not planning around 1,000 different things. They are planning around a small number of identical footprints that the floor already knows how to hold. It is the same logic that made shipping containers change the world. Applied to an aircraft that has to be emptied on a strip somewhere with no equipment waiting. And that yard is its own world with its own rules, which is a story for another day. Today we stay inside the aircraft, where the pallet arrives already finished. Because the moment a pallet crosses the ramp, it stops being cargo in a yard and becomes weight in a specific position, and someone has to sign for that. The ramp is not a doorway, it is a boundary of responsibility. On one side, ground people own the load. On the other side, the crew owns it, and the crew has to fly with it. That is why the person at the ramp checks things that look pointlessly repetitive. Weight tags, documents, whether the item on the tag matches the item in front of them. Not because anyone is expected to lie, because a number written once, early, quietly wrong, becomes part of a calculation nobody can check again once the aircraft is airborne. Now add the complication that makes military airlift different from a freight company. The compartment often carries people and cargo at the same time, not in a separate cabin, in the same space, on seats along the walls, with pallets strapped down a meter away and a net between them. And for the calculation, they are not passengers in any civilian sense. They are weight that walks in on its own, carries its own equipment, sits where it is told, and counts in the calculation exactly like everything else. So a group boarding late is not a scheduling problem. It is a change to the balance of an aircraft that was already planned, and the plan has to absorb it before the doors close. That is one reason people flying on military transport get moved around inside the compartment for reasons nobody explains. It is rarely about comfort. It is about where the mass needs to be, and it is why the safety briefing on these aircraft is given by the same person who supervised the loading. The compartment is theirs. Everything in it, including people, is on their list, which is where that unusual authority comes from. It is not rank. Rank walks onto that ramp all the time and gets stopped anyway. The authority comes from the fact that one person has to hold the entire state of the compartment in their head and be able to state it as a set of numbers on demand. Split that responsibility between two people and you get two versions of the truth. Systems that carry heavy things through the air do not tolerate two versions of the truth. So the rule is deliberately blunt. Inside that compartment, one voice decides what moves, when it moves, and whether it is allowed to stay. Watch a loading operation with that in mind, and it stops looking like manual labor. It looks like a checklist being executed by people who are not allowed to improvise. The vehicle does not simply drive on. It is guided to a mark, stopped on that mark, and then the driver becomes irrelevant to what happens next. Its wheels get chocked. Its suspension may get compressed. Chains go on in a pattern that was decided before the vehicle ever appeared, and get tensioned in a specific order. Fuel gets checked because fuel moves. A half-full tank inside a vehicle inside an aircraft is a small C that can shift when the aircraft maneuvers. Loose items are removed or tied down for the same reason. In a compartment this size, an unsecured object is not untidy. It is something with mass and nowhere it has to stay. And then the whole thing gets walked, physically, end to end, by the person who is going to fly with it. Every lock, every chain, every net. Not because the people who did the work are doubted, because the compartment gets signed for as a single object, and you do not sign for something you have not seen. That walk is the last point where anything can be argued about. After it, the ramp comes up, and the whole system switches from negotiable to fixed. In the air, the job changes shape. It becomes watching restraint, watching the load through turbulence, watching temperature and pressure in a compartment that is a long way from the cockpit and full of things nobody can reach easily. And on some flights, it becomes the opposite of loading. The ramp opens in the air, and everything that was carefully locked down is deliberately released. That is a different discipline with a different set of rules, and it was the whole subject of the last video. Here it is worth 1 point only. The same floor that holds a load still can also release it in seconds. The rails are the reason both are possible with one system. Then comes the arrival and the part that determines whether any of this was worth doing. How fast the compartment empties. Because a transport aircraft on the ground in the wrong place is a liability. Fuel, crew hours, and a runway occupied by something that is doing nothing. So the unload is planned as tightly as the load. Locks come down in a set order. The last pallet in is the first one moving, exactly as the plan said days earlier. And often it happens without any of the equipment you saw at the start. No forklift, no loader, no yard. Just the rollers, the ramp, and the slope. That is the entire point of standardizing the shape. The aircraft can deliver to a place that has nothing because the pallet was designed to leave under its own weight, which is why the compartment looks so bare inside. No shelving, no fittings, nothing permanent that would have to be worked around. Everything that holds cargo folds, retracts, or unbolts because tomorrow the same aircraft may carry vehicles, then pallets, then people, then a medical layout with beds and tiers, and the week after that, all four on the same rotation. The compartment is deliberately unfinished. It is a floor with rules and attachment points, and the configuration is created fresh for each mission. And every reconfiguration is another calculation, because a row of seats is weight, a stretcher rack is weight, and a compartment setup for people balances differently from one setup for freight. Which brings us back to the person walking backwards on the ramp with their hands up, in weather at night, with engines running behind them. Almost nothing they do looks technical from the outside. It looks like directing traffic. It is actually the visible surface of a calculation the crew is going to trust with the flight. And this is the answer to the question people ask when they first see it. Why does one person get to stop everything? Because one person has to be able to say what the aircraft weighs and where. Not roughly, not close enough. As a number at the moment of asking for an aircraft that is about to leave the ground. Everything else in the compartment is built to protect that number. The rails protect it, the chain count protects it, the load plan protects it, and the blunt authority at the ramp protects it from the one thing calculations cannot survive. Someone changing the inputs quietly because they were in a hurry. That is why the system does not rely on judgment at the moment of pressure. The decisions were made earlier, written down, and reduced to steps that can be checked by walking the floor. It is the same design philosophy you find everywhere in aviation. Push the thinking as far ahead of the event as possible, then make the event boring, and boring is the goal. A well-run loading operation has no moments in it. Cargo goes in, gets locked, gets counted, gets walked end to end by one person, and the ramp comes up on schedule. The aircraft then flies as the aircraft was described on paper, which is the entire ambition of the exercise. So the next time you see an open ramp and a stream of pallets disappearing into an aircraft, look at the edges of the picture rather than the middle. Someone is standing where the ramp meets the concrete, not touching anything. Watching each item cross a line, holding a number in their head. That line is where a pile of equipment stops being equipment and becomes part of an aircraft. Everything in this video exists to make that transition survivable. But we skipped a whole world to get here. Before the aircraft even lands, that cargo is already being built into pallets in a yard, weighed and measured by people who never board a plane. Next time, the cargo yard and how a pile of boxes becomes something an aircraft can accept.
Do you need this one?
No. Go ahead, I can work on these.